Somewhere out there, a killer is on the prowl. It moves silently, spreading from pond to pond, river to river, leaving behind a silent trail of death. One by one, frogs are mysteriously disappearing from our world. The warning signs are clear. Our planet is in crisis, and our own future is at stake. Now, a new killer has arrived. One that threatens to wipe frogs from the face of the earth forever.
Hey, I'm Jeff Corwin. You know, for much of my life, I've been pretty blessed because I've had the opportunity to explore gorgeous places like this, telling the stories of the wildlife that live here. And one group of animals that has truly fascinated me are the amphibians, especially the frogs.
My fascination began as a child, searching for frogs in the local pond with my dad. Is this cool or what? Since then, amphibians like the tomato frog in Madagascar,
A toad? Look at that!
and the enormous marine toad in Guyana have taken me all over the world.
Look at the way he did that. He jumped. I can honestly say I would not be here today if it wasn't for frogs.
These brave pioneers emerged from the prehistoric seas more than 300 million years ago, long before the dinosaurs roamed. A whole new world opened up before them, waiting to be colonized. Land. Thanks to their amazing ability to adapt, frogs have colonized almost every piece of land on our planet. They have faced 3 mass extinctions when more than half of life on Earth has disappeared. But frogs have survived every time. And their survival has been important for us too. Lots of our medicines actually come from chemicals produced by frogs. But now they're in crisis, threatened with another mass extinction equivalent to that of the dinosaurs. There are more species of amphibians than there are mammals on the planet, and a third of them are on the brink of extinction. This entire class of vertebrates is being wiped out before our very eyes.
Today, scientists are scrambling around the world to try to unravel this mystery, to try to discover why our planet's amphibians are disappearing. So join me on an incredible journey as we travel around the world on the trail of the vanishing frog.
My journey begins in California. This stunning place is Kings Canyon National Park in the Sierra Nevada mountains. I'm heading 24 miles up the mountain to a protected wilderness zone at 11,000 feet. You're not allowed cars or even helicopters up here, so I'll be sitting in the saddle for 2 long days. I'm going in search of the mountain yellow-legged frog. There used to be hundreds of thousands of them living in these mountain lakes, but recently they started to disappear.
Hey, Vance.
Hey, Jeff.
How you doing?
I'm doing great. How are you?
Oh, my goodness.
Welcome to the basin.
Well, that was not in the brochure. Whoa.
Biologist Vance Vredenberg from San Francisco State University has been studying the frogs in 60 Lake Basin for 13 years.
Let's talk about it at camp. What do you say?
It's easy to see why he keeps coming back. This place is just gorgeous. But things aren't quite as serene as they appear.
And what's the history of this frog?
Well, this frog used to be the most abundant vertebrate in the high Sierra Nevada.
And what's the status now?
Well, in the last 4 years, these guys have been disappearing, dying off right in front of my eyes.
Really?
Yeah. So the site I wanted to show you is right down here.
It looks almost postcard perfect. What is... Oh, Oh my goodness, this is just terrible. Wow.
No matter how much I'd heard about the amphibian crisis, nothing prepared me for this. In one season, the entire frog population of this lake has literally been wiped out.
Vance, what's the impact on the ecosystem to have a lake go from healthy, abundant with frogs, to these animals being extinct in this area?
It's just, it's a really dramatic effect. The first thing it does is it really breaks the food webs between the aquatic and the terrestrial systems. The frogs link them together.
It's hard to believe that such a gorgeous lake could be the scene of this death and destruction. But whatever these frogs in California are suffering from, they're not alone. Frog populations have been plummeting for 3 decades. Around the world, we know of at least 120 species that have gone extinct just since the 1980s. And more than a third of all known amphibians are now in danger. The race is on to find out why.
So this is a pretty good viewpoint up here. We can see what's happened in the basin.
Basically, what we're looking at is almost your entire study area.
Yep.
What happened here?
What's an amazing story. This whole area used to be filled with frogs. And just 4 years ago, something happened. And the frog population down here disappeared, wiped out.
How quickly?
Within 1 season. By the time I came back in 2005,
they were gone.
Yeah. Then 2005, suddenly this next population was infected. By the time I came back, gone. 2006, the next population right up in here.
Right here, this lake.
Yeah, same thing happened. They all got wiped out. Now they're extinct over here. The next lake up, they're infected, but the final lake at the very top of the basin, there's still uninfected frogs there.
So this mysterious frog killer actually swept its way like a wave, killing everything in its path.
Yeah, in a matter of 5 years, it swept right up. I mean, there were thousands of frogs here.
Whatever this mysterious killer is, it's on the move, and it's spreading quickly.
I mean, he's not even really trying to escape.
No.
Look at that.
Wow, he's not looking good. Looks like he's having trouble, huh?
No, he doesn't look good at all.
Yeah, man.
If this were a healthy frog, he'd immediately turn himself over as soon as I lay him on his back.
Yeah, this is some of the typical symptoms that we see with these frogs that are dying up here. They get rigor in the muscles. They don't do the riding response correctly. They're totally lethargic. Now, you don't see any discoloration or anything, but obviously something's very wrong with this frog. When we first started finding dying frogs like this, we had no idea what was going on. And this is not something that herpetologists find naturally in nature. You don't find dead frogs.
So then, Vince, what was it? What's killing these frogs?
Well, we were pulling our hair out, trying to figure out what was going on here. The entire scientific community could not figure out what was happening. And finally, someone looked very carefully at the skin, and they found out that the skin was infected with a microorganism, and it was a fungus.
A fungus?
Yeah, an aquatic fungus. It's called Batrachochytrium dendrobatitis.
The fungus lives in the water. It decomposes dead plants and animals. But a new strain has recently emerged that can penetrate the skin of living frogs and salamanders. Amphibian skin is really remarkable. It's so permeable that water and oxygen can pass through it, but this makes it easy for the fungus to get inside too. The skin reacts by going into overdrive, producing extra layers of cells until the skin is so thick that the frog literally can't breathe or absorb water through its skin. Ultimately, the frog dies from a disease called chytrid. In this one lake, the numbers have dropped from 850 frogs to only 15 in a single season.
What's the prognosis here?
It's not good. I think if you come back in a few months, you won't find any.
So, is there anything you can do?
Well, we're experimenting with some antifungal treatments of these animals out here in the wild. And that's the best we can do right now.
So really, we're on the front lines when it comes to trying to deal with this epidemic.
The situation is so desperate that Vance is single-handedly trying to save the frogs one by one.
Hey, we got frogs right here.
Look at this.
Wow, he's not even resisting. Look at that.
Look at that. Amazing.
He's experimenting with the fungicide treatment that he hopes will buy them some time to build up their own immunity.
That looks good, though.
It's a simple but daring plan. First, he inserts a tiny pit tack under the skin of an infected frog so that he can identify this frog in the future.
Well, it's really important for us to know whether these experimental treatments are working or not. And by keeping track of the infection dynamics on each individual, we'll know whether it worked or not.
Then, the frog gets to take a bath in fungicide.
So what's happening here is that the fungicide is killing off the infection of the frog, and we're trying to give the frog enough of a window of opportunity to build up its own defenses.
So to build up its resistance.
Exactly, to the disease. And then we're going to release him back into the lake, and hopefully he'll have enough of his own defenses now to fight off the disease.
All right.
But we won't know whether the treatment is actually working until the end of the season. Saving the mountain yellow-legged frog seems almost impossible. Vance must find a way to stop the fungus from moving up the valley. It won't be long before every lake is infected.
We're now about to head to the top of the basin, to the only lake in this area that is not infected by the deadly chytrid fungus. It still has a healthy population of frogs. So we're going to move through a chytrid-free zone, and the last thing we want to do is carry the chytrid fungus on our feet. How much water?
All it takes is just one drop of infected water.
Yeah, that's how we isolate our areas.
But there is a weapon available for fighting the fungus:
Capful.
Yeah,
bleach.
that's all you need. We just need a weak bleach solution.
What scientists have discovered is that the simple act of disinfecting their shoes and equipment will help slow the spread of chytrid.
Yeah, that's all it takes. Okay, we're kitchen free. Look at these guys.
The difference is immediately clear. Healthy frogs are everywhere.
Yeah?
No, these guys are quick, man.
Oh,
These
here we
guys.
go. Oh, here's two right here. Look at this. There's another one. Look at this guy. Come here, buddy. Here, we got this nice pack.
Here you go. I got one too. Look at this.
Nice.
And these frogs, though, they're different. They're alert.
Yep.
They're quick. And I think this is what a yellow-legged frog
It's supposed to look
supposed to look
yeah,
like.
you
It's
bet.
supposed to behave
These
like.
guys are looking good.
At last, I get to see some healthy frogs.
There's a bunch of tadpoles right there. Let's catch some tadpoles. Just avoid those muddy, those sandy areas. See those big black guys? Those are our friends. Just a few years ago, there were tens of thousands of frogs in this basin. And now we're down to this lake right here. There's probably maybe 200 frogs here.
It's not just yellow-legged frogs that are in trouble here. Chytrid seems to be threatening all amphibians in the park.
You get this water seeping over the...
All that is, except one. The Pacific chorus tree frog.
Come here. Come on, buddy.
For some unexplained reason, there are still loads of them living up here in the Sierras.
You can hear them. I mean, this pond is filled with these chorus tree frogs, and it is the classic ribbit.
Well, here's the really interesting thing. These guys, they live in the exact same place where the yellow-legged frogs live, and they're not dying the way that the yellow-legged frogs are.
Which begs the question, what do these tree frogs have that the yellow-legged frog does not have?
We still don't know the answer to that question. You know, they must have some different kind of defense. That's a question we desperately have to answer.
It's time for me to leave and continue my investigation. But I'm going to come back later in the season to see how these frogs are doing. One thing's for sure, my few days in the mountains have made me realize the enormous challenge scientists face if they're going to save the world's amphibians.
It seems as though nothing is out of reach of the deadly chytrid fungus, and it may be just a matter of time before all the unique and wondrous species of amphibians, the frogs and the salamanders that live here in this national park, could be gone forever. The great question is how did the deadly chytrid fungus get here? To understand that, that's where I'm off to next. Come on. Look at that.
Wow, he's not looking good.
I now know it's killing the frogs up in California's mountains, a disease called chytrid. But where it came from remains a mystery. To answer that, I need to do a little detective work. Scientists believe chytrid first started killing frogs in North America in 1961. One by one, frogs in other continents started dying too. In fact, the only continent with amphibians that hasn't reported chytrid is mainland Asia. But the really big clue lies in Africa. In 2004, a group of scientists went to several museums in southern Africa and analyzed nearly 700 preserved dead frogs, some 100 years old. They made a dramatic discovery. The first case of chytrid in Africa appeared in 1938, 23 years before it showed up anywhere else. The infected frog was one of these right here. This is the African clawed frog, Xenopus laevis. This frog may look harmless enough, but there's a very real possibility that it is carrying the deadly chytrid fungus, the same fungus which is wiping out California's yellow-legged frogs. These frogs live throughout much of Africa. They've been exposed to the chytrid fungus for decades and have now developed resistance to the disease. They simply carry it around in their backs, transporting the lethal fungus wherever they go. But the issue of concern with this African clawed frog is, we're not in Africa. This is a pond in California. So the million-dollar question is, what is this frog doing here? It all began in 1934. Long before women could buy over-the-counter pregnancy tests, scientists developed an ingenious technique using the African clawed frog. They discovered that if you inject one of these frogs with urine from a woman who's pregnant, her hormones will cause the frog to ovulate, confirming the woman's pregnancy. After this incredible discovery, thousands of African clawed frogs were exported around the world for laboratory research. Hidden within their skin was the killer fungus. These non-native frogs have been carelessly released from laboratories and also through the pet trade, and now are well established in the wild, like here in California. Eric Larson from the Department of Fish and Game has a real problem on his hands. He thinks there are hundreds, if not thousands, of African clawed frogs in this pond, and he's trying to get them out.
These frogs are known carriers of the chytrid fungus, and that can carry from one location to another. As the populations in a pond like this expand, the frogs disperse, and they can carry that chytrid fungus to a native environment where there may be yellow-legged frog or red-legged frog.
Because of the spread of the African clawed frogs, native frogs all over the world are now being exposed to chytrid, and they are dying. There are countless reasons why we need to protect our planet's amphibians, especially when it comes to the environment and biodiversity. But the thing is, human beings, we benefit from amphibians as well, especially with medicine, where there's a really big payoff. Chemicals derived from frog skin are used to make many different medicines for people, such as antibiotics, painkillers, treatments for ulcers, and for high blood pressure. And frogs are even proving critical to the latest developments in cancer research. At the University of California, Berkeley, Professor Tyrone Hayes is learning that frogs have a lot they can teach us about hormones, breast cancer, and possible links to pesticides like atrazine.
The hormone imbalance created by atrazine, the decline in testosterone and increase in estrogen, is causing these males to first become sterile, and some of them completely transform into females, even though they're genetic males.
What is the connection between the impact on frogs and the impact that atrazine could have on our species?
Yeah, the testosterone and the estrogen that are affected in these animals are the exact same hormones that are present in us.
And high levels of estrogen in humans is known to be linked with breast cancer and maybe prostate cancer. And here's the real kicker.
The level that atrazine is causing breast cancer cells to make estrogen, the levels that causes infertility and that cause sex reversal in our frogs are levels that are equivalent or lower than what's allowed in our drinking water right now.
So these studies with frogs are showing us that chemicals considered safe in our drinking water may in fact be linked to certain cancers. Clearly, there's a lot we can learn from amphibians, which makes it so important that we save them. But it's not just frogs that are dying. Salamanders are suffering too. To find out why, I must leave California and head to the rolling hills of Missouri in search of a creature so bizarre, it's called the hellbender.
See something? What percentage of amphibian species are threatened with extinction? Is it A, 10%, B, 25%, or C, 33%? What percentage of amphibian species are threatened with extinction? The answer is C. At least a third of the known amphibian species are currently threatened with extinction.
I've seen for myself the dramatic impact chytrid is having on amphibians, and I'm determined to help find a way to save them.
From the majestic peaks in the Sierras of California, we now find ourselves here meandering along this pristine waterway, this river in Missouri. We've come to this place to better understand a most incredible species of salamander. It's called the hellbender. It happens to be the largest species of salamander throughout the Americas. It also happens to be a creature that is now endangered.
Just since the 1990s, the number of hellbenders has dropped by an incredible 80%. That has herpetologist Jeff Brigler with the Missouri Department of Conservation seriously worried.
Well, we face many challenges trying to protect this species. Habitat changes, water quality issues, even poaching.
And what about chytrid?
Well, that's one of the recent discoveries. We found the amphibian chytrid fungus on hellbenders in Missouri. Today we're going to canoe to one of our known hellbender sites on this river, and we're going to search real hard. Hopefully we'll find several hellbenders, and we're going to test them for chytrid fungus.
Hellbenders grow up to 2 feet in length, but are almost impossible to find. Jeff's been searching the entire state of Missouri for 5 years, and he's only tagged 55. Hopefully, we're gonna find a couple of monster hellbenders, and you're gonna see why they call them hellbenders.
Not a hellbender.
Don't let go there, buddy.
Hey, Mark, will you help me with this rock? See something? Get that side there, and I'll get this one, and we'll pull it back with current. On 3.
We got one! What? You got a hellbender!
I told you there was a monster living here. And I told you you'd find out why they called them hellbenders. Now, I don't know why I'm talking like this, but when you hold this creature, you kind of do want to talk like this. This is a hellbender. My God, he's absolutely gigantic. It's like a prehistoric creature from a sci-fi movie.
Pretty good. So what are we going to do now?
Hopefully, this hellbender will help us understand why these incredible animals are dying.
Okay, the first thing we're going to do, we'll grab this guy and we're going to try to put him on his back here. And the first thing we're going to do, we're actually going to physically swab him for chytrid. So if you can lay him in here on his back, and if you can for me.
Boy, they are slimy.
Just firmly. That'll be fine. So this cotton swab should absorb any of the fungus zoospores, but we definitely want to get all the feet.
Yeah.
So that's more likely. There's more keratin in the feet
So that's where the chytrid fungus would more likely be found.
The team will analyze the samples back at the lab. How invasive do you think the fungus is throughout the United States, or the world for that matter?
Well, the more people are testing, it appears that this fungus is very widespread. It's probably in almost every body of water across the U.S.
Really? Why should we protect these animals? There are so many creatures on our planet. What's the importance of the hellbender?
It's very important in our rivers. It's part of our biodiversity. But more importantly, I mean, you look at this pristine river, these animals absorb everything that's in this river. So we drink this water.
So, if something's hurting the salamanders, it could be hurting us too. What's particularly alarming is the fact that hellbenders in Missouri have unusually low sperm count. And so do the men.
Other species,
Human beings.
Yep, there's found the sperm count to even be lower here in Missouri.
These animals could provide valuable information about our own reproductive health. That makes sense?
Yes.
So 41 centimeters and 24 grams. Really? Once we're done measuring and tagging and disinfecting our field equipment with a bleach solution, we put the salamander back exactly where we found it.
So the best thing to do is we'll just, right in front of this rock, all right, we'll just set him, kind of get up in here and just set him right on the bottom.
Hopefully this hellbender will survive another season and continue to breed. There are fewer and fewer juveniles making it to adulthood. It's a tragic story that's put the hellbender on Missouri's list of endangered species. So, what is the prognosis for this species?
Well, if you'd asked me that question 2-3 years ago, I would have said in 20 years we wouldn't have a hellbender in Missouri anymore. But due to all of our efforts, there is hope for this species.
What they're trying to do is breed them in captivity at the St. Louis Zoo, something no other institution has managed to achieve. So Jeff, we're stepping on that bleach solution to keep disease out, so we can assume that this is a chytrid-free zone.
That's correct.
So what's happening here?
Well, we have a simulated 32-foot stream we've built here.
And there's hellbenders in here?
Yes, we have 6 males and 3 females in here.
Preserving hellbenders in captivity may be the only way to ensure their survival. But it's only going to work if the captive animals start to reproduce. While the zoo staff are waiting for the adults to mate, they're already raising juveniles from eggs caught in the wild.
So how do I know that this animal right here...
But 2 years ago, disaster struck. The juveniles became infected with chytrid. Treating them with fungicide didn't work. So the zoo had to find another way to kill the fungus without harming the salamanders.
You ready?
The solution was a little unorthodox. Now, when you found out that you had a chytrid outbreak, what'd you do?
We took these systems right here, raised the temperature very slowly, about 5 degrees Fahrenheit a day, till we reached 90 degrees.
You did it with the animal in the tank. You didn't actually remove it.
That's correct. We did it with the whole system.
By slowly heating the water to 90 degrees and keeping it there for 3 days, they were able to kill the fungus without harming the animals.
So it was the first time that we know of that that's been done with aquatic salamanders.
Since that outbreak, bleach has been used to keep the facility chytrid-free. When these juveniles are old enough, they'll be released back into the wild to help restore local populations.
We've got this beautiful hellbender right
But life in the wild is anything but easy. And chytrid isn't the only problem. Frogs are now showing up with serious deformities. 3 legs, male and female sex organs, missing limbs. The cause could be environmental pollutants like pesticides, which mimic hormones and disrupt the frog's development. And what's affecting frogs may well be affecting us too, through our own drinking water. Amphibians could be our canaries in the coal mine. The question is, will we heed the warning in time? The chytrid fungus is killing frogs and salamanders throughout the United States. But the impact of this disease is global in scale. My investigation takes me to the mountain forests of Panama, home to the beautiful golden harlequin frogs. Chytrid fungus first appeared in Costa Rica in 1987. In 1993, it reached Panama. It has spread rapidly, averaging 15 miles per year. Since then, 90% of all frogs living in Panama's cloud forests have died. Nestled in the forest, El Valle Amphibian Conservation Center houses some of Panama's most endangered amphibians. As species after species disappears in the wild, scientists believe their only hope for survival is to collect the few remaining specimens and breed them in captivity.
Something needs to be done. It needs to be done in Panama. And the best thing we can do right now, because we can't stop it in the wild, is to sequester some animals, bring them into the safety of captivity, and protect them until we figure out a way either to impart immunity to the animals or environmentally control the chytrid fungus.
Each frog they save is treated with fungicide to remove any chytrid,
Run it through the PCR machine to see if
then carefully photographed before entering the breeding program. This precious female harlequin frog, Atelopus varius, is one of the last of her species ever to be found in Panama. She's healthy, but there's a crisis.
The problem that we have with this female is that they are all gravid.
So when you say gravid, her belly is loaded with eggs. You can sort of see that cream-like coloration.
And what we found in December was just a bunch of females, 8 of them total, and no males. They were all in the stream waiting for the males, but there was no males around.
Without a male, this female can't release her eggs.
He grabs her here and he gives her kind of like a massage, and he stimulates her to lay the eggs, and the fertilization is an external fertilization.
If this gravid female doesn't release her eggs soon, she will die, just like some others in her group have already.
So how many eggs do you think are inside her?
It's gonna be at least 400 to 1,000 eggs.
And this otherwise healthy animal, the missing link is the male.
It's critical that the remaining females avoid the same fate if this species is to survive. So, we head out into the forest in search of a male. But the Atelopus varius harlequin frog has not been seen here in the wild for months. It may already be extinct in Panama, another victim of chytrid.
Not get a better representation of a rainforest than what's around us, yet it's eerily quiet when you listen. Not a chirp, not a croak. There are just no frogs here.
The male harlequin frogs are the hardest hit. They live close to water all year, so they're always vulnerable to chytrid. Finding an adult male isn't looking good. But then...
What? Golden frogs, 2 of them.
What?
Babies, golden frog. There's one here.
Yep. How small is it?
Real small.
They're just so tiny.
They're babies, maybe 2 weeks old.
Look at this. 2 absolutely precious, incredibly valuable harlequin frogs. Another one? Oh my goodness. Look at this. So tiny. We got another one, huh?
Yes.
Oh my goodness.
It seems miraculous to find so many.
Jeff, this right here might be the key to the survival of the species, of a whole species. But another one, yeah.
Oh my goodness. Look at this. Such a wonderful discovery. We've got a bag here of about a dozen of these little Panamanian harlequin golden frogs, but we could be very well looking at the last generation of a species.
We don't know yet, though, if any of them are males. Either way, they're much too young to help the female back at the lab that desperately needs to mate. So our search for an adult male continues.
The thing is, you just can't give up hope. There's, a little thing there. I just saw something. Oh my goodness. Eduardo! Look what's hiding under this log. Watch this. There we go. This is what it's all about. We have found an adult specimen. Eduardo, come here, buddy. If it's a male, this could very well be the solution to stopping extinction in its tracks. Question for you. What would you say if I showed you this?
Oh my God. Look at this. Jesus. Where was it?
It was right here. Is it a male or is it a female?
Oh, this is a young female.
It's a young female.
Yes.
It's not a male, which is really what we wanted, but it's a young female.
It's still an incredible discovery since chytrid has wiped out nearly every frog in this forest. This young adult female and the other babies we found could form the basis for a successful breeding population in captivity.
If you were here a year ago, there would be thousands of these frogs scattered throughout these rocks. Today, we have found only one. This could be the very last adult golden frog in the wild. But hopefully, this little creature will bring more frogs into the future.
Our next destination is Sierra Llorona, a forest reserve 100 miles to the northeast. It's precariously located just ahead of the advancing wave of chytrid.
Edgardo, how big is this forest here?
This private reserve is about 200 hectares.
We're going in search of Atelopes lamosus, an endangered species of harlequin frog that's only recently been discovered. Edgardo is anxious to find some adults for the captive breeding program before chytrid reaches this forest and wipes them out.
For me, that's pretty remarkable to think that even today we're discovering new species, but this mission really is a race against time. Are we going to get to this frog before the deadly chytrid fungus does? So this is the stream right here?
Yes.
We're going to disinfect our sandals and our pant legs before we go into the stream. Because if we had contacted the chytrid fungus on the way here, we don't want to introduce it to an area where it's free.
Here's one. There's a whole bunch. 1, 2. Are those females?
Hopefully.
So here's the creatures that we're looking for. They're incredibly small. If you look, if you just follow my finger, There's another one. This, right there, boop, he just jumped. This is the Atelopes right there. He's actually right on Eduardo's shoe. Of course, it's probably good that you scrubbed your foot, isn't it?
These harlequin frogs are endangered throughout much of Panama. But chytrid hasn't reached this forest yet, and here the frogs are still everywhere.
We just jumped over there.
Where?
Right by it.
Where? Oh, there it is. Look at this. Now that is a very...
That's big.
That is a big frog.
Okay, relatively speaking.
Yep. And it's quick.
And got an orange belly. Oh,
Got an orange belly.
it has all the promising signs. Edgardo,
Yes.
I think we've got something here.
We've got two.
But 2 frogs?
It's very productive. We're seeing lots of these Atelopes.
Okay, now,
Now this one looked larger.
I don't want to lose it, so. Can you get it? Got it. There we go.
Oh yeah. Oh yeah.
That's a female.
Yeah, it is a female.
This is the first female ever in captivity. And once
Is
it's
that true?
Yes.
going to be the first one.
So this species was discovered 10 years ago. And Eduardo, how many times in the field have you ever witnessed this frog?
Females?
Yeah.
Never. This is the first time I've seen a female in the wild. Here you go. That's a male.
That's a male?
Yes. You see there's a couple differences
Well, look at the bellies
here.
on them.
You see
Oh,
the
wow,
bellies
you
here,
can see
how different they are.
Right now, we have only males of this in captivity. If we hope to save them, and if we can't stop the chytrid fungus from killing the wild populations, this little girl is going to be very important.
It's been a really successful expedition. Before taking the frogs back to the breeding center, we swabbed them for chytrid just in case. Fortunately, both the female and male look healthy. But in just a few months' time, this story could be very different.
Is it a matter of if or when it comes to chytrid hitting this place?
Unfortunately, is when. Here, this is a private reserve, so here we don't have to worry about habitat loss. But chytrid doesn't know boundaries. It doesn't respect any limits. Or
Doesn't
if
know
it's
boundaries.
a protected area, it just moves through it, kills everything, and continues moving and stays in the place. Once a place gets infected, chytrid will never leave.
But scientists still don't really understand why chytrid has exploded around the world in the last few decades. Why now have so many amphibians started to die? One theory, climate change. Over the last 30 years, the temperature has risen, the deadly fungus has appeared, and frogs have been dying. Could there be a connection? That's what I'm going to try to figure out next.
Why are amphibians so important in our world? Is it A, chemicals in their skin play an important role in medical research? B, they're indicator species, alerting us to poor environmental quality? Or C, they act as natural pesticides, eating insects that damage crops and spread disease? Why are amphibians so important in our world? The answer is all of the above. Chemicals in their skin play an important role in medical research. Amphibians are indicator species, alerting us to poor environmental quality. And they also act as natural pesticides, eating insects that damage crops and spread disease.
In countries like Panama, entire species of frogs have been wiped out by chytrid in recent years. But there's also been a significant increase in temperature. The possible link between chytrid and climate is the subject of a great scientific debate. In search of answers, I head to the island of enchantment, Puerto Rico. The coqui frog is the national icon. It's a cultural love affair that began hundreds of years ago with the Taino Indians who lived in the forest. Frogs symbolized fertility and decorate many of their artifacts. But I've come to Puerto Rico to see living frogs, and for that, I head into El Yunque National Forest at night.
When it comes to amphibian diversity, Puerto Rico is very special. This land is home to 19 endemic species of frogs, which means they're found nowhere else in the world but here. But tragically, since the arrival of the chytrid fungus, 3 of those species are now believed to be extinct.
In the forest, the coqui are slowly disappearing. Rafael Ogler and Patricio Barros from the University of Puerto Rico have been studying these nocturnal frogs for years. It's breeding season, and we can hear them all around us.
Oh, there it is. Oh, look, Jeff.
This is a male. He's calling for two reasons. First, to defend his territory from other competing males, and also to attract any females in the area. The coqui don't lay their eggs in water. Instead, they use pockets of trapped water within curled leaves or inside the funnels of bromeliads.
Right here.
You can't see it, but underneath this male is a clutch of eggs. There they are. You can actually see the embryos moving. The coqui are direct developers. They go straight from eggs to baby frogs without any tadpole stage.
When the male guards the eggs, we usually get 100% survival of all the eggs.
And that's not going to keep chytrid at bay, though?
No, they still get affected by chytrid. We think the chytrid arrived in Puerto Rico in the early 70s, and we saw population declines, particularly in the mid-70s, and also at the beginning of the 90s. We lost species, and we saw the declines. We were able to record them.
So, Patricia, those declines that you guys saw in the 70s and the 90s, possibly from chytrid, but do you think there's maybe a climate connection?
Yes, we think so, and that's what we're trying to figure out.
Chytrid arrived in Puerto Rico more than 30 years ago. Since then, the temperature in the rainforest has risen by 2 degrees Fahrenheit.
Now, an increase of just 2 degrees Fahrenheit in temperature may not seem like much to human beings and other mammals, but it's totally different when it comes to amphibians. These creatures are highly sensitive to changes in temperature in the environment. So an increase like that in temperature could mean the difference between life or death.
There's also been an increase in extended periods of drought. And these dry spells coincide with when the frogs were dying in the mid-70s and 90s. So, the real question is, what happens to the frogs during a drought that makes them more vulnerable to chytrid?
We're just starting to understand this.
That's what Patricia is trying to figure out.
Here we have a terrarium where half of the terrarium is kept very dry and the other one is humid. And what we observed is that they moved to their wet side. And when we inoculated these frogs with chytrid, the frogs that are under this dry regime, then forced to clump, die off much faster.
And the same thing is happening in the forest.
Climate change has caused more periods of drought in the Caribbean. It stresses them for lack of water. They will move to the small pockets of the forest where there is humidity. That's where the chytrid is more likely to be. They're clumping so they can give it to each other, and you get a die-off, you get a decline, and these frogs are sick from chytrid mycosis.
Clearly, increasing drought caused by climate change is affecting the outbreaks of chytrid, and scientists are now beginning to understand that relationship. But there's one big riddle that remains. Why are some species dying from chytrid while others aren't? This is the Melodius coqui. In the early 80s, they completely disappeared from the forest, but now they're coming back.
How did it do it?
We don't really know how they did it, but it was very interesting to see the population come back. And there's a possibility that they have some natural defenses against pathogens like the chytrid fungus. For example, they may have some natural occurring bacteria in their skin that allows them to defend themselves.
Scientists are desperately trying to understand why some frogs, like the Melodius coqui and the Pacific chorus frog, are now able to survive chytrid. At James Madison University in Virginia, they're one step closer to solving that riddle. Reed Harris and his research assistants have found that the naturally occurring bacteria on the skin of some frogs is enabling them to survive chytrid. When certain bacteria from frog skin are added to a culture of chytrid, a clear zone appears where the fungus has been killed.
So that's telling us that some of these naturally occurring bacteria on the skin of the frog are potentially able to fight off the chytrid fungus. If we can enhance the population size of this bacteria, then the frog itself will be able to fight off the chytrid.
So basically, you allow this frog to take a bath in a concentrated solution of bacteria.
And then we'll expose it to the chytrid fungus and see if there's a protective effect.
The test subjects are mountain yellow-legged frogs, the same frogs that are dying in the Sierras. Normally, exposing a frog to concentrated chytrid like this would certainly kill it.
What are your results from this study?
Well, what we found, and we're pretty excited about this, is that when you give them the protective bacteria first, then expose them to the chytrid fungus, we got 100% survival.
That's incredible. So we're actually now getting proof that there is a potential solution to killing this deadly chytrid fungus. So it's gone from 100% fatal to 100% survivability from the mere presence of that bacteria.
Exactly, exactly.
The implications are huge. Not only could bacteria strengthen the natural defenses of frogs bred in captivity before they're set free, but if the bacteria were added on a larger scale to lakes or soil, which is something farmers do all the time, this treatment could potentially save populations of frogs out in the wild.
So that would be the next step in this study, would be, can we do something like this in the field?
It is the first glimmer of hope that somehow, someday, we may be able to stop the onslaught of chytrid. But that day is still a long way off. Up in the Sierras, Vance Vredenberg can't afford to wait that long. His frogs are dying now.
Wow, he's not even resisting. Look at that.
Despite the odds, he's been attempting the impossible to save the frogs with chytrid out in the wild.
And so we'll put him in this bath.
I've returned to see whether his experimental treatment with fungicide has been working. This is an infected pond where Vance began treating the frogs 2 years ago.
There's one right here.
Oh, yeah.
There we go.
Awesome. Got him.
When I return with him, he's really happy with the results.
Well, this is the frog pond that actually gives me hope, because the disease has swept through this whole area, killed all the other frogs, yet in this lake, they're still doing pretty well.
Thanks to the presence of a pit tag Vance inserted 2 years ago, we know this is a frog he previously treated with the fungicide. Clearly, the treatment worked and is the only reason there are any frogs alive in this pond.
Well, there's probably close to 50 frogs in this little tiny pond. These are the only frogs in this area that have survived the wave of this disease. So there's some hope.
With his fungicide, Vance Vredenberg is single-handedly saving these frogs from chytrid, literally one by one.
There's still hope. There's some hope.
There you go, buddy.
There she goes.
It's a small yet encouraging ending to my investigation into the global amphibian crisis.
I think out of all the wildlife journeys I've had in my life, this one has been one of the more memorable journeys.
Oh my God. Look at this.
We've learned that amphibians not only play an incredibly important role in our planet's ecology, but are also beneficial to the human species. So perhaps, in the end, by protecting our planet's amphibians, we protect the future of the human species. All of us from Animal Planet, the Clorox Company, Amphibian Ark, and many members of the scientific and conservation community would like to thank you for tuning in to this extraordinary and powerful story. Tragically, while we can't bring back the species we've lost, we still may have a chance to save those species that remain with us. To find out how you can help, please go to SaveTheFrog.com. Together, if we act now, we can make a difference.